Good evening, everyone. Welcome to another lecture of GATE Aerospace Engineering. As you all know that we have recently started this series aiming to cater for GATE 2026 aspirants. And yesterday we covered an important topic of structures, that was torsion in thin walled members. And today we are going to cover another very important topic, that is Airy's stress function. Lot of questions come from this particular topic every year, and we are not only going to cover Airy's stress function, we are going to cover other topics also, because we cannot directly dive into the topic of Airy's stress function without understanding these other topics. So we are going to talk about a little bit about stress tensor, although I will assume that you might know something about stress tensor, so we will have a quick revision of this topic. Then we are going to understand equilibrium equations and compatibility equations, and then we will understand Airy's stress function. You cannot understand Airy's stress function without the knowledge of equilibrium equations and compatibility equations. All these topics are written in the syllabus of structures special topics. As you know that the syllabus of GATE Aerospace contains two types of topics: core topics, special topics. So the special topics in structures has mentioned these topics: equilibrium equations, compatibility equations, Airy's stress function. And in today's session, everything related to these topics will be covered. We are going to solve a lot of numericals also. We will solve all the PYQs related to these topics. So I hope you guys are excited. Now, those of you who are seeing me for the first time, let me introduce myself a little bit. My name is Apuroop Rao, All India Rank 320 in GATE Mechanical in GATE 2010. MTech from IIT Kharagpur in Mechanical Systems Design. Then I was placed at Mahindra Research Valley, where I worked for 2 years. And then I decided to start teaching for GATE and ESE. So I have been teaching for more than 10 years now, almost 11 years now. And my favorite subjects are strength of materials, vibrations, theory of machines, machine design, engineering mechanics, etc. Okay. And in GATE Aerospace, here at GATE Wallah, in GATE Aerospace, I teach strength of materials. Chalo. If you want to ask any doubts regarding your preparation or regarding the technical problems, then you can join this Telegram group. This is the name of the group. You can either search by this name or you can scan this QR code. So this is a closed group of all the students preparing for GATE and ESE. Okay. Chalo. So let's start without any delay. Okay. So first let's understand about stress tensor. Let's have a quick review of stress tensor. What is a stress tensor? Okay. Let's say that you have a body which is subjected to a lot of external loads. Okay, you can see in this diagram, there is a body, it is subjected to three-dimensional loading: P1, P2, P3, P4, P5. These loads are three-dimensional. Okay. Now, if you cut this body using any plane, then at any point on that plane, you will get a lot of internal forces also, right? You can see you have cut this body using this plane. There is a point on this plane, and at this point you are going to get a lot of internal forces, right? Now all these internal forces can be resolved into two components, right? You can have two resultants of all these internal forces. One will be normal to the plane and one will be parallel to the plane. Okay. Now you can resolve all these resultant forces into three components. See, one component is normal, other is parallel, but this parallel component is right now inclined at some angle. So we can resolve this into two components, right? Two rectangular components. So now you have three internal forces at this point. One is normal to the plane, other two are parallel to the plane. One is in x direction, other two are in y and z direction. Okay, this is clear to everyone. So this body was subjected to a lot of external forces. We have cut this body using a plane, and at particular point we are getting three internal forces, one in X, one in Y, one in Z. One is normal, other two are parallel. Now internal force per unit area is called stress. If the internal force is normal, it will be a normal stress, and if the internal forces are parallel, they will be shear stresses. So beta, due to this force which is normal to the plane, we are going to get a normal stress, and due to these two forces which are parallel to the plane, we are going to get shear stresses. That means at this plane, on this plane, at any point you are going to get three stresses, one normal, other two shear. Just like this, there are two other planes, means we have total three mutually perpendicular planes. At every plane you get three stresses, one normal, other two parallel, one normal, other two parallel. So in total, at any point inside the body, you get these 9 stress components, right? Now these 9 stress components can be written as a matrix also, a 3 by 3 matrix. I hope you guys know about this topic. So this can be written as X, Y, Z, X, Y, Z. How is it written? See, the first component will be XX, sigma XX. Then the second one will be XY, tau XY. Third one will be XZ, tau XZ. Okay. Then this one will be YX, tau YX. This one will be sigma YY. This one will be tau YZ. Then this one will be tau ZX. Then tau ZY. Then sigma ZZ. So we are getting 3 by 3 matrix, total 9 stress components, and this is known as a stress tensor. It's not scalar, it's not vector, it's a tensor. Now there is a property of this matrix. It is a symmetric matrix. What do we mean by symmetric matrix? Symmetric matrix means the elements above and below of this diagonal are same. Means tau XY is equal to tau YX, tau XZ is equal to tau ZX, and tau YZ is equal to tau ZY. This is known as complementary shear stress, right? Tau Yx is the complementary of tau Xy, tau Zx is the complementary of tau Xz, tau Zy is the complementary of tau Yz. Okay. So beta, at any point, if you want to calculate stresses, you need to know the values of all these 9 stress components, right? But this is 3-dimensional stress. In most of the members of aircrafts, we get 2-dimensional stresses. Why? Because usually the members of aircrafts are made of sheet metal, which is very thin, right? Sheet metal means it's a thin sheet of metal. So by using these sheet metals, different components of aircrafts are made. And if you have a thin plate, you can ignore the forces perpendicular to the plate. So we can assume that all the loads are within the plane of this plate. Means we can assume that the stresses developed are within this plane only. That means the stresses are biaxial. There is no stress in this direction, in Z direction. All the stresses are in XY plane. So instead of these 9 stress components, we only get 4 stress components, right? We get sigma X, we get sigma Y, we get tau xy and tau yx, but tau xy and tau yx can be written as tau xy only, right? Here you can see that instead of sigma xx, I am only writing sigma x. Okay, so it's okay, you can understand that, right? If you write it in matrix form, you will get a 2 by 2 matrix. Okay, so in strength of materials, we only study about biaxial stresses or plane stresses. We don't study three-dimensional stresses usually. Okay, most of the problems that come in your exam, almost all the problems that come in your exams are related to only two-dimensional stresses. Okay, so this is something a little bit about stress tensor. Now, before coming into Airy stress function, we need to understand two things. We need to understand equilibrium equations and compatibility equations. Without understanding these two topics, we cannot understand Airy stress function. So let's first understand equilibrium equation. You know already what is an equilibrium equation, right? If you have studied engineering mechanics, equilibrium equation means that the resultant force and resultant moment must be zero. For a body to be in equilibrium, the resultant of the forces and moments must be zero, right? Summation of fx equals to 0, summation of fy equal to 0, summation of fz equal to 0. So you have understood these equations. Now you can write those equilibrium equations in terms of stresses also. See, usually what happens when we draw this diagram, on this right face and left face, we apply sigma x. So we write this is sigma x, this is also sigma x. This is sigma y, this is also sigma y. This is tau xy, this is also tau xy. But actually, if the stress on one face is sigma x, then on the other face, stress will be slightly greater or lesser than sigma x. Right, slightly, because it is a very small element. So the stress from this phase to this phase will not change drastically, it will only change slightly. So if you draw the actual diagram considering the change in stress from one phase to another phase, from this phase to this phase, it will look like this. Can you see? Here if the stress is sigma x, then here the stress will be slightly greater or slightly lesser. You can consider this minus or plus, it doesn't matter. So right now I am assuming that it is slightly greater. So if this is sigma x, I am considering this to be sigma x plus dou sigma x by dou x into dx. What is dx? See, dx, dy, dz are the dimensions of this element. So this is dx, this length is dy, this is dz. Okay, this is dx, this is dy, this is dz. Okay, so these are the dimensions of this element and we are looking at only one face of this element. Okay, we are looking at this front face. This is dx and this is dy. Okay, we are not showing dz because we have only two-dimensional stresses. So you can see that if this is sigma y, this is sigma y plus dou sigma y by dou y dy. Similarly, if this is tau xy, this is tau xy plus dou tau xy by dou x dx, and if this is tau yx, this is tau yx plus dou tau xy by dou y dy. Okay, now let's apply equilibrium equation. So if this element, if this body is in equilibrium, the net force in x direction should be 0, net force in y direction should be 0. So let's apply the equilibrium equation. Let me write summation of fx should be 0. Okay, now in the x direction, what is the total force? Let's consider the right side force to be positive, left side force to be negative. But remember, these are stresses, these are not forces. So if you are writing this equation, you have to convert stress into force. How you can convert them into forces? By multiplying with area. For example, all these stresses are acting on this plane, right? What will be the area of this plane? The area will be dy into dz, na? It's a rectangle, so dy into dz. So if you want to convert these forces into, these stresses into forces, you will multiply with dy dz. Then all these stresses are acting on this plane, What will be the area? Dx into dz. Okay. So let me convert this into a force. So it will be sigma x plus dou sigma x by dou x dx. This is the stress multiplied by this area, which is dy into dz. Okay. Then we have this force also in positive x direction. So this is tau yx plus dou tau yx divided by dou y into dy multiplied by, this is acting on this area, which is what? Dx into dz. So these two forces are in positive x direction. Then this force is in negative x direction, sigma x, which is also acting on dy dz plane. So it will be minus sigma x into dy dz. Then this tau yx is also in negative x direction. So minus tau yx into dy dz equal to 0. So we have considered all the forces acting in x direction here by equilibrium equation. Now look at this. This will become sigma x into dy dz, and this is also minus sigma x into dy dz. So this and this will be cancelled. Similarly, tau yx into dx dz and minus tau yx into dx dy dz. This is dx dz. So these two will be cancelled. Okay. So you will get dou sigma x by dou x into dx dy dz. Okay. Plus dou tau yx by dou y into dy dx dz equal to 0. Now this dx dy dz, this is also common. So if you take that out, what you are going to get? Dou sigma x by dou x plus dou tau xy, you can write tau yx as tau xy, both are equal, by dou y equal to 0. This is your first equilibrium equation by applying summation of fx equals to 0. Similarly, if you apply summation of fy equal to 0, you are going to get dou sigma y by dou y plus dou tau xy by dou x equal to 0. If you want, you can do that. Okay, if you want, you can write summation of fy equal to 0, and by using the same steps, you are going to get this second equation. So we have two equilibrium equation. This is equation number 1. This is equation number 2. What are these equations? These are equilibrium equations. So at any point, if you have sigma x, sigma y, tau xy, they must satisfy these equations. But sir, why are we deriving these equations? What is the significance of them? We are not going to put the values of sigma x, sigma y, tau xy, na? Usually we calculate stresses 100 megapascal, 200 megapascal, so we can't put them here. So why are we deriving this equation? You will understand the significance of this later. Right now, I hope you have understood how we are getting these equilibrium equations. Okay. Now, the next thing that you need to understand is compatibility equations. Let me explain the concept of compatibility equation. You might have studied compatibility equation somewhere, but till now a lot of you might not have understood the physical meaning of compatibility equation, right? So let me explain it to you. Let's say we have a deformable body, okay, elastic body. Let's divide these elastic bodies into several rectangular elements. Okay. Now consider 4 rectangular elements from here. 1, 2, 3, 4. Right now I am assuming they are not deformed. Okay. Now after applying all these loads, these elements will get deformed. Okay. If you deform this element number 1, let's say you are stretching this in x direction, you are stretching it in y direction. So if you deform this element number 1, it will disturb element number 2, 3 and 4 as well, because it is connected to them. So the particles of element number 1 will disturb the particles of element number 2, element number 3, element number 4. Yes. Similarly, if you deform element number 2, this will also disturb all these other elements, right? So let's say I have deformed them, element number 1, element number 2, element number 3, element number 4, and now I am integrating them again. First I have considered their deformation separately. Let's say element number 1 is deformed like this, then element 2 is deformed like this, element 3 is deformed like this, element 4 is deformed like this, and now I am connecting them back. So initially they looked like this. It was a continuous body. There were no gaps between them. So after deformation also, if I connect them, there should be no gap, right? They should not look like this. What is this? What is happening in this diagram? According to this diagram, if I deform all these elements separately and I am connecting them, they are not connected properly. They are not continuous. There are gaps between them. But this cannot physically happen, right? Physically, when you deform a body, all these elements are still together, right? So beta, their deformations should be in such a way that after deformation also they should be connected properly like this. See, this is undeformed diagram, this is after deformation. Here also there are no gaps, here also there are no gaps. So physically, do you understand what it means to be compatible? Now understand the mathematical meaning behind it. When we calculate strain, then all these strain values should be connected together, means epsilon x, epsilon y, gamma xy, all these strain components are connected together in such a way that they should ensure that we are getting this diagram, not this diagram, because epsilon x, epsilon y, gamma xy, all these are not independent of each other. They should be connected so that this happens, this does not happen. So there is an equation, mathematical equation known as compatibility equation in terms of epsilon x, epsilon y, gamma xy, so that we can ensure that after deformation we get a continuous displacement, a continuous body. That equation is written as dou square epsilon x by dou y square plus dou square epsilon y by dou x square equal to dou square gamma xy by dou x dou y. Epsilon x, epsilon y are normal strains, gamma xy is shear strain. Okay, so they are related to each other using this equation. This is compatibility equation in terms of strain. What is it? It is compatibility equation in terms of strain. But we need compatibility equation in terms of stresses also. And we know by Hooke's law, there is a relation between stress and strain, right? What is that relation? According to Hooke's law, epsilon x is equal to 1 by E sigma x minus nu sigma y. Epsilon y is equal to 1 by E sigma y minus nu sigma x, and gamma xy is 2 into 1 plus nu by E tau xy. Sir, how we are getting this third equation? We know these two, but how we are getting this? Understand, E is equal to 2g into 1 plus nu. You know this equation, na? So tau x, this is gamma xy is actually tau xy by g, but we are writing g in terms of E and nu, so we are getting this. Okay, so these are the relations between stresses and strains. So what we can do, we can put the values of strains from these equations into these equations, and after simplifying we get this equation. I am not getting into the mathematics because see, I will have to solve all these differential equations. I am not getting into that mathematics. I am directly writing the equation. You will get this: dou square by dou x square plus dou square by dou y square sigma x plus sigma y equal to 0. How we are getting it? By putting the values of epsilon x, epsilon y, gamma xy into this equation and solving the equations, we are getting this equation. Okay. Now, this can be written as delta square. It is a Laplacian operator. This is what? This is known as compatibility equation in terms of stress. This is compatibility equation in terms of strain, and this is compatibility equation in terms of stress. Okay. Now, why we are studying all this? Why we are studying equilibrium equation, compatibility equation? Why are you not telling us directly the Airy stress function? So let's understand now what is Airy's stress function. See, at any point in a body, if you want to calculate stresses, you need to find the stress component sigma x, sigma y, tau xy, right? Now, Airy's stress function is actually a function in terms of x and y. It's a continuous function in terms of x and y, so that by using this function, you can find the values of sigma x, sigma y, tau xy at different values of x and y. For example, let's say this is an area. Okay, you need to find the values of sigma x, sigma y, tau xy at different points of this area. Okay, so if I give you a function so that you can directly calculate stresses at different points of this area, it will be very easy for you, right? That single function is known as Airy stress function. Airy stress function is denoted by phi. It is denoted by phi. So if you have this equation of phi, you can calculate all these stresses at different points of the area. How? So Airy stress function is defined like this: sigma x is equal to dou square phi by dou y square. Sigma y is equal to dou square phi by dou x square, and tau xy is equal to minus dou square phi by dou x into dou y. Okay. So if you know the equation of phi, then by using these relations you can find sigma x, sigma y, tau xy. Reva, it will become very easy, right? Because you can find the values of all these stresses at different points over the entire area. At different points you can find the values of stresses using this single function. It will give you the entire, what can I say, distribution of stress. For example, let's say the stress is varying linearly. So stress is varying linearly. So it will give you the entire relation, entire equation of stress, sigma x, sigma y as well as tau xy, by using one single function phi. One single function you can find all the stresses. You don't have to find the equation of sigma x separately, sigma y separately, tau xy separately. That's what we do in usually, right? For example, let's say when you calculate bending stress, you are finding the equation of sigma x. When you are calculating torsional stress, you are finding the equation of tau xy. But here we are only using one single function and we are getting all these stresses, right? Easy. But how will you find the value of phi? Because you cannot arbitrarily choose any equation for phi, na? You cannot arbitrarily choose any function. It has to satisfy certain equations. Which equations? It has to satisfy equilibrium equations as well as compatibility equation, right? See, whatever equation of sigma x, sigma y, tau xy you get, it should satisfy these equilibrium equations and it should also satisfy these compatibility equation, right? So we need to ensure that the phi satisfies both these equations. So how we are going to ensure that? See, this is the compatibility equation. For deriving this compatibility equation, we have already used equilibrium equation. Okay. Now, if you put this here, delta square, or you can write this, dou square by dou x square plus dou square by dou y square, sigma x plus sigma y equal to 0, right? Or you can say delta square into sigma x plus sigma y equal to 0. Now if you put this sigma x and sigma y here, then it will become like this, delta to the power 4 into phi equal to 0. What is this? This is known as biharmonic equation. Biharmonic equation. What is the significance of this equation? If you use this equation, if the function phi satisfies this single equation, it automatically satisfies equilibrium equations as well as compatibility equation. You don't need to separately satisfy them because we have already derived all these equations using equilibrium and compatibility. Now, so if you put the equation of phi here and if you satisfy this equation, then equilibrium equation and compatibility equation both will be satisfied. Is this clear? I hope this is clear. So now let's understand how actually the equation of phi is chosen. We will take a simple example, okay? Let's take a simple example. let's say phi is ax square plus by square plus cxy. Okay, I am just choosing an arbitrary equation. Now we know that this equation must satisfy this equation, right? Then only this will be valid. Okay, what is sigma x? Acha, first of all, if you put it here, it will automatically satisfy, because here we have only x to the power 2 and y to the power 2, and here we are differentiating it with respect to del to the power 4 by del x to the power 4, del to the power 4 by del y to the power 4, so it will automatically satisfy. So you can see that whatever function I have chosen, it is satisfying this equation. So this is okay. Okay, this is okay. We can use this. Now, what will be sigma x? It will be del square phi by del x square, right? So if you differentiate this entire equation partially with respect to x, what you will get? This will become 0. After differentiating 2 times, this will become 0. After differentiating 2 times, this will become what? 2a. Similarly, sigma y is, sorry, oh, so sorry, this should be dou square phi by dou y square, na? Dou y square, so sorry. So this will be 2b, and sigma y will be dou square phi by dou x square. So if you differentiating this 2 times, it will get 2a, these two will become 0, tau xy will become dou square phi by dou x into dou y. So these two will become 0 because this has only x, this has only y, and we are differentiating with respect to x as well as y. So these two will become 0 and this will become minus c. This is negative. Okay. So sigma x will be 2b, sigma y will be 2a, and tau xy will be minus c. If you draw them on this diagram, what you are going to get? See, this will be sigma x, this will be sigma y, both are positive, and tau xy is minus c. So if tau xy is negative, it should be in this direction, right? If you are drawing it like this, positive, drawing it like this, negative. So this is 2b sigma x, sigma y is 2a, and tau xy is c, minus c. Okay, so you can see that we are getting constant values for sigma x, sigma y, and tau xy, because we have chosen the function in such a way. But if, let's say, the stresses are linearly varying, they are not constant, they are linearly varying, so you need to choose a function in such a way that this should be cubed, right? Then you will get these equations in terms of x and y. So they will linearly vary. If you want parabolic variation, then this should be to the power 4, right? Sir, can we choose any function like this? Beta, see, this should satisfy this equation as well as the boundary condition. What is boundary condition? For every problem, you will get some boundary condition, means there will be some values of sigma x, sigma y, tau xy on the boundary. So the function should also satisfy the boundary condition. Let me give you an example. Okay, let's say you have this type of problem. Let's say you have a bar which is fixed at this point and it is subjected to sigma x at this end. Okay, it is subjected to sigma x. Let me write it sigma naught. Okay, let's say the x is here, the y is here. This is x, this is y, so this is my origin. Okay, let's say the length is L and the width is 2h. Why I am taking 2h? Because this is, let's say, h, this is, let's say, h. If you take it h, then this will be h by 2, no issue. Let's say this length is L. So this is the problem. Now understand what do I mean by boundary condition. Here on this boundary you can see that sigma x is equal to sigma naught, right? And here on this surface sigma y is 0, tau xy is 0. So these are boundary conditions. On the boundary of the problem you have certain values of sigma x, sigma y, tau xy, na? So they should be satisfied. Okay. Let's choose the polynomial again. Let's choose the Airy's function phi. Let me write it ax square plus by square plus cxy. Again, it will satisfy the biharmonic equation, right? It will satisfy the biharmonic equation because we are differentiating to the power 4 and here maximum x power is 2, maximum y power is 2. So if you differentiate this equation in terms of x and y 4 times, obviously you will get 0, na? So it is satisfying the biharmonic equation, but it should also satisfy the boundary conditions. Okay, so understand, at x equal to L, here sigma x is equal to sigma naught, na? So at x equals to L, sigma x should be equal to sigma naught. So let me write sigma x. What will be sigma x? It will be dou square phi by dou y square, which will be equal to how much? 2b, right? And this should be equal to how much? This should be equal to sigma naught. So from here I can say b should be equal to sigma naught by 2. Yes or no? B should be equal to sigma naught by 2. Similarly, another boundary condition we have, at y equal to plus minus h, sigma y must be 0. So sigma y is dou square phi by dou x square, which will give you 2a, and this should be equal to 0 because sigma y is 0. So beta, from here a will become equal to 0. Okay. Similarly, tau xy is also 0 on the boundary. So tau xy will be minus of dou square phi by dou x into dou y, which will give you how much? It will give you minus c. So this should be 0, means c should be 0, right? So beta, now you have the Airy stress function. Phi will be equal to c. A is 0, C is 0 and B is sigma naught by 2. So it will become sigma naught by 2 into y square. So this is the Airy stress function for this problem. It is satisfying both biharmonic equation as well as the boundary conditions. Is this point clear to you? It is satisfying both biharmonic equation as well as the boundary conditions. Now some of you might be wondering, sir, how we are going to understand which polynomial we have to choose, because in every problem we cannot choose this type of Airy stress function, right? For different problems we have different types of stress functions. So how we are going to choose that? Do we have to remember all these things? Beta, understand, you don't have to find the Airy stress function for different problems. In GATE exam, you will get certain types of problems. You should just know the concepts of Airy stress function and you can solve all these problems. You don't have to worry about choosing the Airy stress function. We are not going to get those type of problems. Okay, you only need to understand how to solve these GATE problems based on Airy stress function. Okay, so let's see what type of questions you get from Airy stress function in GATE exam. Okay, we will solve every variety of problem that has come in GATE till now. Okay, I have seen all the different types of problem and I have brought all these problems, different variety of problems. After solving all these problems, let me tell you, your concept of Airy stress function will be clear and you will be able to solve every GATE PYQ, every numerical. Okay, let's start with the first problem. This was in GATE 2020 and this was a 1 mark problem, very simple problem. Okay, which one of the following conditions needs to be satisfied for phi equal to ax to the power 4 plus by to the power 4 𝐂𝐲𝐬𝐞 to be considered as an Airy's stress function? Understand what they are saying. You need to satisfy Airy's stress function. So which of these equation will satisfy this function phi? Now I told you, in order to be Airy's stress function, biharmonic equation has to be satisfied, na? So just put the biharmonic equation here, solve this and tell me which equation are you getting. It's a simple problem. All you need to do is satisfy the biharmonic equation. What is biharmonic equation? Del to the power 4 phi, right? So this phi is ax to the power 4 plus by to the power 4 plus 𝐶𝐻𝑦 cube. Okay, if I differentiate it with respect to x 4 times, what you are going to get? See, this will become 0 because it does not have any x. This only has x to the power 1. So after one time it will become cy cube, and then if you differentiate it again second time, it will also become 0. This has x to the power 4, so this can be differentiated 4 times. If you differentiate it 5 times, then it will become 0. But if x to the power 4 is there, you can differentiate it 4 times. It will not become 0. So if you differentiate it 1 time, you get 4ax cube. 2 times, you get 12ax square. 3 times, you get 24ax. 4 times, you get 24a. So if you don't understand it like this, you can write it manually. You can write one by one. Differentiate it 1 time, then 2 times, then 3 times, then 4 times. So you are going to get 24a. Similarly, dou to the power 5 by dou y to the 5 by dou y to the power 4, and this will become 24b. Okay. Now what is the biharmonic equation, beta? Dou to the power 4 by dou x to the power 4 plus dou to the power 4 by dou y to the power 4 phi equal to 0, right? So you are going to get 24a plus 24b equal to 0. So a plus b equal to 0. This is the answer. Means C is the correct answer. If you satisfy this equation, a plus b equal to 0, this means this is the correct stress function, Airy stress function. Is it clear? This was only for 1 mark and this was from GATE 2020. Okay, so by now you might have understood a little bit about what type of problems you are going to get, right? They will give you the Airy stress function. You just need to find all these constant values in most of the problems. You just need to find these A, B, C, either the values of them or the relation between them. Okay, let's solve another question. Let's solve this one. This is from GATE 2010 for 2 marks. What is the problem? Following stress state is proposed for a 2-dimensional problem with no body forces, sigma xx. What do we mean by body forces? Body forces means weight. Okay, weight is a body force. Okay, so the body forces are not considered in the equation that we have seen. We have neglected them, and here also in the question also it is written no body force. Sigma xx, sigma yy, tau xy equations are given. Now they are saying it satisfies equilibrium equation but not compatibility equation, compatibility equation but not equilibrium equation, neither equilibrium equation nor compatibility equation, both equilibrium equations and compatibility equation. So it is not directly based on Airy stress function, but they are based on equilibrium and compatibility equation, which we have also seen. Okay, so what you need to do is you need to put these values into equilibrium equations and compatibility equation, and you need to check whether they are satisfying them or not. So first we will check equilibrium equations. Okay, let's check equilibrium equations. So what is the equilibrium equation? The first equilibrium equation is dou sigma x by dou x plus dou tau xy by dou y equal to 0, right? So put the value here, dou sigma x by dou x. So if you differentiate it with respect to x one time, this will become 0 and this will become 6xy. Then dou tau xy by dou y. So if you differentiate it with respect to y one time, this one will become 0 and this one will become minus 6xy. And it is being 0. So the first equilibrium equation is satisfied. Okay. Second equilibrium equation is dou sigma y by dou y plus dou tau xy by dou x should be 0. So let's see whether it is 0 or not. So dou sigma y by dou y, if you differentiate it with respect to y, this will become 3y square and this one will become 14x. So 3y square plus 14x. Then if you differentiate it with respect to x, so what will be this? 6xy and 14x. Wait a moment. If you differentiate it with respect to x, this will become minus 3y square and minus 14x, right? Minus 3y square and minus 14x. This is also becoming 0, right? If you differentiate it with respect to x one time, this will become minus 3y square will become minus 14x. 3y square plus 14x minus 3y square minus 14x, 0. It means equilibrium equation is satisfied. Okay. Now let's check compatibility equation. What is compatibility equation? Dou square by dou x square plus dou square by dou y square sigma x plus sigma y equal to 0, right? So dou square by dou x square plus dou square by dou y square. Let me put it sigma x plus sigma y. So 3x square y plus 4y square. 3x square y plus 4y square. And sigma y is y cube plus 14xy. Y cube plus 14xy equal to 0. So first you will have to differentiate this with respect to x 2 times. Then you will have to differentiate it with respect to y 2 times. What you can do? Del square by del x square, 3x square y plus 4y square plus y cube plus 14xy plus dou square by dou y square, 3x square y plus 4y square plus y cube plus 14xy. Okay, I should not write it 0 because right now I don't know whether it is 0 or not. Okay, so if I differentiate it with respect to x 2 times, see here there is no x, it will become 0. Here there is no x, it will become 0. Here x is only 1 time, x to the power 1. So you cannot differentiate it 2 times, it will become 0. You can differentiate this one 2 times, so it will become 6y, right? The first term I am getting 6y. Then if you differentiate this with respect to y 2 times, what you are getting? This will become 0 because y to the power 1. This will become 0, y to the power 1. This and this have y to the power 2 and y to the power 3. So this will become 8, right? And this will become 6y. So this is not getting 0, right? So it means that compatibility equation is not satisfied. So what is the answer? Equilibrium equation is satisfied, but compatibility equation not satisfied. Right? Equilibrium equation is satisfied, but compatibility equation is not satisfied. Is this clear? Okay. Let's move on to the next question. The Airy stress function phi equal to alpha x square plus beta xy plus gamma y square. Again, they have given you the Airy stress function for a thin square panel of size 1 by 1 automatically satisfies compatibility if the panel is subjected to uniform tensile stress sigma naught on all 4 edges. The traction boundary conditions are satisfied by. We need to satisfy the boundary conditions. Okay, they have written that it automatically satisfies compatibility equation. You can see x and y have maximum power 2, so it will automatically satisfy the compatibility equation because to the power 4, if you differentiate it 4 times, it will automatically become 0. Now we need to find whether they are satisfying the boundary condition. What they are saying, the panel is subjected to uniform tensile stress sigma naught on all 4 edges. So it's something like this. This is sigma naught, sigma naught, sigma naught, sigma naught. This is the boundary condition. We need to satisfy this boundary condition. Okay. Phi is alpha x square plus beta xy plus gamma y square. Now you have two options to solve this problem. One, you can either use the elimination method. What does it mean? It means that you can eliminate these options, whether it is satisfying the compatibility equation, whether this is satisfying the compatibility equation. So by eliminating one by one all the wrong option, you will get the right option. Or you can directly use the compatibility equation to find the values of alpha, beta and gamma. Okay. So what is the compatibility equation? See. First of all, sigma x, sorry, I'm saying compatibility equation, boundary condition. First of all, sigma x is equal to what? Dou square phi by dou y square. So if you differentiate it with respect to y 2 times, this will become 0, this will become 0, this will become 2 gamma, right? And what is sigma x? Sigma x is equal to sigma naught. So this is equal to sigma naught. So from here, gamma is sigma naught by 2. Okay. Similarly, sigma y will be equal to dou square phi by dou x square. Okay. Dou square phi by dou x square. So if you differentiate it with respect to x 2 times, this will become 0, this will become 0, this will become 2 alpha. And sigma y is also sigma naught. So from here, alpha will be sigma naught by 2. Then tau xy is minus of dou square phi by dou x into dou y. Okay. So if you differentiate it with respect to x and y, this and this will become 0, this will become minus beta. And tau xy is 0, right? There is no tau xy here. So tau xy is 0. So from here, beta will be 0. So alpha is sigma naught by 2, beta is 0, gamma is sigma naught by 2. Sigma naught by 2, 0, sigma naught by 2. So A is the correct answer. Clear? Right now we don't have the test series because we have just launched GATE Aerospace. We have just launched our paid batch, first paid batch for GATE 2027. So we are just starting right now. So maybe next year we will launch a full GATE test series. For this year we don't have a GATE test series. But if you want, you can start your preparation right now also. You can enroll in the batch also. Most of the subjects might be completed by the next year. Okay. Chalo. Let's move on to the next topic. Next question, sorry. Which of the following Airy stress function could satisfy the given boundary conditions, assuming constant values of sigma xx equal to p, sigma yy equal to q, tau xy equal to r along the boundary? So here also in this problem, we need to satisfy the boundary conditions. Okay. We need to find the values of, we need to find the equation of phi which satisfies the boundary condition. Okay. So again you have two options. One, you can either use the elimination method, means you put the equation of phi and you satisfy it and you see which one is correct. Or what you can do is choose an arbitrary function of phi. See, all these are like this na, in terms of x and y, ax square plus by square plus cxy, right? Now we just need to find the values of a, b and c. All these four options, looking at these four options, I can say that phi is in this term, ax square plus by square plus cxy. We need to just find the values of a, b and c. So how we can find the values of a, b and c? See, you have the boundary condition, right? Sigma xx is p, sigma yy is q, and tau xy is r. So put the value sigma xx dou square phi by dou y square. So if you differentiate it two times in terms of y with respect to y, this and this will become 0, this will become 2b. And what is sigma x? It is p. So from here b is p by 2. Okay. Then sigma y dou square phi by dou x square. So we need to differentiate it with respect to x. This and this will become 0, this will become 2a. And what is sigma y? Sigma y is q. So from here a is equal to q by 2. Then tau xy is minus dou square phi by dou x into dou y. So if you differentiate it with respect to x and y, this and this will become 0, this will become minus c, and tau xy is r. So from here c is equal to minus r. So now we have the values of a, b and c. Okay. So put the values here in this. So phi will be equal to ax square and a is q. So q x square by 2. Similarly, b is p by 2. So p y square by 2 and c x y. So minus r x y. This is the Airy stress function. Qx square by 2 plus py square by 2 minus rxy. Qx square by 2 plus py square by 2 minus rxy. C is the correct answer. Qx square by 2 plus py square by 2 minus rxy. C is the correct answer. Yes. Okay. I hope you guys are understanding everything. Please let me know in the comment section if you are getting all this. It will really help me to understand whether I'm going in the right direction or not. So this was the question from GATE 2011. Okay. Let's solve another. I hope that now you have understood which type of problems there will be in GATE exam and whether you will be able to solve them or not. All you need to do is only satisfy these equations, okay? Boundary conditions, compatibility equation, equilibrium equation, biharmonic equation, etc. Okay. Thank you so much, Darshini, Harsha. Thank you so much, Tushar, for the compliment. So GATE 2018 2 marks question. What is the question? The components of stress in a body under plane stress condition in the absence of body forces is given by sigma x equals to ax square, sigma y equal to 12x square minus 6y square, and sigma xy is 12xy. Coefficient A such that body is under equilibrium is. You need to satisfy the equilibrium equation and find the value of A. You just need to satisfy the equilibrium equation, okay? So what is the equilibrium equation? Dou sigma x by dou x plus dou tau xy by dou y is equal to 0, right? So this will become dou by dou x of sigma x is ax square, then dou tau xy. Tau xy is this 12xy. So dou by dou y of 12xy equal to 0. So this will become 2ax plus, if you differentiate it with respect to y, 12x equal to 0. So from here I am getting a equal to minus 6. Such an easy question, right? A is equal to minus 6. So if this is the value of A, it will satisfy the equilibrium equation. You just needed to solve one equilibrium equation. Yes? Everyone is clear? This is from GATE 2018. Okay. If you are thinking that sir is only solving easy problems so that we will get the confidence, beta, you can choose any arbitrary question based on this topic from GATE PYQs. Okay, you have the GATE PYQs with you. Choose any question randomly from this topic and you will be able to solve it if you know all these concepts. Okay. This is from GATE 2024. Consider the plane strain field given by epsilon x is this much, epsilon y is this much, gamma xy is this much. A is constant and gamma xy is the engineering shear strain. Value of A for the strain field to be compatible. So here we need to use the strain compatibility equation. Okay, they have given the equation of strain epsilon x, epsilon y, gamma xy. We need to use the strain compatibility equation here. Okay, what is the strain compatibility equation? Do you guys remember? What is the strain compatibility equation? Strain compatibility equation is dou square epsilon x by dou y square plus dou square epsilon y by dou x square equal to dou square gamma xy by dou x into dou y. So you need to put the values in this equation and you will get the value of A. So dou square epsilon x by dou y square, what you are going to get? Dou square by dou y square of 10xy square. So if I differentiate this in terms of with respect to y 2 times, first time I will get 20xy, second times I will get 20x. Okay, then dou square epsilon y by dou x square. So dou square by dou x square, what is epsilon y? Minus 5x square y. So if I differentiate this with respect to x 2 times, one time I will get minus 10xy, 2 times I will get minus 10x. Yes, then dou square gamma xy by dou x into dou y. So dou square by dou x into dou y of gamma xy. What is gamma xy? Axy 2x minus y. So let me multiply everything. So this will become A is common, na? So A is constant. A will come out. And you are going to get 2x square y minus xy square. 2x square y minus xy square. So let me differentiate it with respect to x one time and y one time. So if you differentiate, A is here. If I differentiate it with respect to x one time, it will get 4xy, and y one time it will become 4x. then if I differentiate it with respect to x one time, it will get y square, and if I differentiate it with respect to y one time, it will become minus 2y. Okay, now I will put all the values in this equation. So this will become 20x minus 10x equal to a into 4x minus 2y. Am I making some mistake? This is 10y, na? So sorry, this is 10y. So here I can take 5 common and it will become 4x minus 2y, and this is a into 4x minus 2y. 4x minus 2y, 4x minus 2y will be cancelled. So a is equal to 5. Very good, Deva Darshini. Very good, very good, very good. A equal to 5. Okay. So a little bit of calculation is needed. That's it. All you need to do is put these equations into this compatibility equation. That's all. Okay. Chalo. Let's move on to the next question. Now this is from GATE 2016. Two-dimensional state of stress in a body is described by the Airy stress function. So we have given again the Airy stress function. The Airy stress function will satisfy equilibrium and compatibility requirements if and only if the value of coefficient E is. See, here the equation of phi is given and we need to satisfy both equilibrium and compatibility requirements. Now I told you, you don't need to satisfy equilibrium equations and compatibility equations separately. All you need to do is just use the biharmonic equation. If biharmonic equation is satisfied, then both equilibrium equations and compatibility equations are satisfied. Okay. After substructure with subject start. Beta, right now we are studying strength of material. Then from tomorrow, Ramanand sir will start vibration also. So after strength of material and vibration, we will start some subject. We will see. Which subject do you want us to start after structure? Just satisfy the biharmonic equation. What is the biharmonic equation? Delta to the power 4 phi equal to 0, or dou to the power 4 by dou x to the power 4 plus dou to the power 4 by dou y to the power 4 into phi equal to 0. We need to satisfy only this equation. Okay. So dou to the power 4 by dou x to the power 4 into phi. What is phi? 5x to the power 4 by 12 plus x cube y by 6 plus 3x square y square by 2 plus 7xy cube by 6 plus ey to the power 4 by 12. So if I differentiate it with respect to x 4 times, what I am going to get, beta? What I am going to get? See, if you are differentiating with respect to x 4 times, only the terms which have x to the power 4 or greater will come. All the other terms will become 0. Okay. Wait a minute, something is wrong. Here there will be another term. 2 this will be like this. Dou to the power 4 by dou x to the power 4 plus dou to the power 4 phi by dou y to the power 4 plus 2 dose to the power 4 phi by dou x square dou y square equal to 0. Okay. So if I differentiate it with respect to x 4 times, what you are going to get, beta? This term, this term, this term, and this term will also become 0, right? Or I should just directly put it here, na? By looking at this equation. Why wasting time? So only this term has x to the power 4, na? So all these other terms will become 0. X to the power 4. So 4x cube, 12x square, 24x. So 5 into 24 divided by 12. Then here, if I differentiate it with respect to y 4 times, so this will become 0. This one will become e into 24 by 12. Okay. And dou square phi, 2 into dou square phi by dou x square dou y square. So 2 into, if I differentiate with respect to x 2 times and with respect to y 2 times, see, only the term which has both x and y to the power 2 or more will be there. This will become 0, this will become 0, this will become 0, this will become 0. Only this will be there. So 2 into 2, 4, 3, 12 by 2, 12 by 2 equal to 0. If you are not able to do it in your mind, write everything here, okay? Means differentiate with respect to x 1 time, then x 2 times, then y 1 time, then y 2 times. You can step by step write everything so that you don't make a mistake, okay? So this will become 10, this will become 2e, and this will become 12. So 22 by 2, e will be equal to minus 11. Are you getting this? Are you getting this? E is equal to minus 11. So I have made a mistake in writing this operator, Laplacian operator. Okay, in some other problem, in the first problem also, I have made this mistake. Although the answer was right, but here it should be like this. I don't want you guys to make the mistake I made. That's what I was thinking, that I am making some mistakes. See, this term was 0, so no issue. Okay, because if you differentiate this 2 times, this 2 times, this will automatically become 0, na? That's why we got the correct answer, because this term became 0, but I forgot to write this term. Okay, so I am really sorry. So here E is equal to minus 11. Okay, very good, Tushar, very good. Chalo, let's move on to the next question. Now this is from GATE 2014. A cantilevered beam is subjected to parabolic distribution of shear traction at the right edge, while the top and bottom surfaces are traction free. To solve this problem, following Airy stress function is proposed. Phi equal to C1xy plus C2xy cube plus C3x square y square plus C4x cube y. This is an admissible Airy's function that would satisfy the biharmonic equation as well as the boundary condition if and only if C1, C2, C3, C4. We need to find these 4 constants. C1, C2, C3, C4. We need to satisfy the boundary condition, okay, and we also need to satisfy the biharmonic equation, okay. So by satisfying all these, we will find C1, C2, C3, C4. So this, we have one biharmonic equation and we need three boundary condition. Okay, one biharmonic equation, three, because we have four unknowns, na, C1, C2, C3, C4. So we need one biharmonic equation and three boundary condition. Let's see. So the first one is the biharmonic equation. What is the biharmonic equation? Del to the power 4 by del x to the power 4 plus del to the power 4 phi by del y to the power 4 plus 2 dels to the power 4 phi by del x square into del y square equal to 0. This is the biharmonic equation. So we need to put the equation of phi here. So x to the power 4, none of them will survive. So this will become 0. Y to the power 4, also none of them will survive because maximum power of x and y is 3. So this will also become 0. Here x to the power 2, y to the power 2. Where are you getting? In the first, second and fourth term, the power of x and y 1. So these terms will become 0. This will become 4c3, right? 4c3. 2x into 4c3. This will become 4c3 equal to 0. So from here I am getting c3 equal to 0. So I have got the first value, c3 equal to 0. So A, B and D can be the answer. C cannot be the answer because here c3 is lambda, which is not correct. C3 is 0. Okay. So biharmonic equation is used. Now we need to use the boundary conditions. What is the boundary condition? Look at it. On the top and bottom surface, there is no traction. On the top surface and bottom surface, sigma y is equal to 0. Na? Here on this surface, there is no stress. Sigma y is 0. Here also sigma y is 0. Okay. What is sigma y? Sigma y is rho to the power 4 phi by, sorry, not rho to the power 4, rho square phi by rho x square. Na? So C3 is already 0. If you differentiate it with respect to x 2 times, the first one will be gone, second one will be gone, third one is already gone, fourth one will survive. This will become 3c4 x square y, then 6c4 xy, 6c4 xy, which is 0. So from here c4 will also be 0, right? Sigma y is 0, na? So 6c4 xy. We are differentiating it with respect to x 2 times. So one time it will become 3x square, 2 times it will become 6x. So 6c4 xy is 0, means c4 should be 0. So c3 is 0 and c4 is 0, means A cannot be the answer. So C cannot be the answer, A cannot be the answer. Only B and D can be the answer. So C3 0, C4 0, C1 will be lambda, right? Because in both options C1 is lambda. So let's see how we can get C1 equal to lambda. See, here this variation of tau xy is given. Can you see? Can you see this variation of tau xy? Let me draw it for you. This is the variation of tau xy that is given here. If you are not able to look at it properly, this is the variation of tau xy. And the equation is written like this. Tau xy is minus lambda 1 minus y square by d square. Okay. So you can see that the maximum value of tau is at the center, right? Maximum value of tau is at the center and it will be minus lambda. See, maximum value of tau xy can only be minus lambda. From this equation you can see whatever value of y you will put, maximum this can become 1, okay, at y equal to 0. So you are getting the maximum value of tau xy here where x is 0, y is 0. Why I am using this? Because in this boundary condition both x and y will become 0. So this will be the easiest boundary condition, that's why I am putting it. So at x equal to 0, y equal to 0, tau xy will be minus lambda. So let's find tau xy first. What is tau xy? Tau xy is minus dou square phi by dou x into dou y. What is happening? Minus dou square phi by dou x into dou y. Okay. So C3 and C4 has become 0. So if I differentiate it with respect to x and y, so this will become minus C1. Okay. X will be gone here. This will become minus 3 C2 y square. Right? Minus C1 and minus 3 C2 y square. Okay. Okay. So this is tau xy, and what is the boundary condition? At x equal to 0 and y equal to 0, tau xy will be minus lambda. Okay. So put here. So it will be minus lambda equal to, this will become 0. So C1 will be equal to lambda. Okay. Then at y equal to plus minus d, tau xy is equal to 0, na? At top and bottom, the value of tau xy is 0. So at y equal to plus minus d, tau xy is 0. Y plus minus d, see this is 2d from the center. This is the origin. So plus d minus d. So at top and bottom both tau xy is 0. So whatever value you want to put, y plus d or minus d, doesn't matter. So this will become 0 equal to, this will become minus lambda minus 3c2 y square. What is y square? Acha, y is d. So it will become d square. Even if you put plus or minus, doesn't matter, right? So from here c2 will become lambda by 3d square minus lambda by 3d square. Right? C2 become minus lambda by 3d square. What about C3 and C4 terms? Beta, C3 and C4 are already 0. Haven't you seen this? C3 is 0, C4 0. So why are you worried about C3 terms and C4 terms? They are already 0, na? So C1 is lambda, C2 is minus lambda by 3d square. So lambda and minus lambda by 3d square. So D is the correct answer. Okay. Yes, very good, Tushar. D is the correct answer. So C3 and C4 became 0, and now we have calculated the value of C1 and C2 by the boundary condition. So what was the boundary condition? At y equal to 0, tau xy is minus lambda, and at y equal to plus minus d, tau xy is 0. This variation of tau xy is given, na? So from here, at y equal to 0, tau xy will be minus lambda, and at y equal to plus minus d, tau xy is 0. Okay. All right. So I think by now you might have understood what type of problems you might get from Airy stress function, and I think you will be able to solve all those problems, right? Am I correct or am I correct? So by now you might have got the confidence in this particular topic, Airy stress function. Okay. So tomorrow Ramanand Bansal sir is going to explain the concept of rotational vibration, another very important and very interesting topic from structures. Okay, and he is also going to explain 2 degree of freedom system, which is considered to be the toughest concept of structures. Okay, one of the toughest concept of structures. So don't forget to join tomorrow at the same time, same place, to understand the concept of vibration also. Okay. Aerodynamics after structure, okay, we will see, we will try to start aerodynamics also. Thank you so much, bye bye, take care, Jai Hind.